So a lot of people in my travels talk about their CMMSs, and it's a controversial question. Are they fat? Are they lean? So what I want to do is talk about, how they can be lean, how they're sometimes fat, and really investigate this topic carefully. Now, first of all, there's waste. The biggest amount of waste is in the hours of labor input. I don't know what it's like for you, but most organizations waste a lot of labor on the input side. They may spend 20 hours per hour of output or 50 hours per hour of output. The second biggest waste is the third one here, that you can't make decisions because the data is garbage. And we'll talk about that. And then there is some waste in the labor and paper outputs. Now, many of you are using your system every day to run your maintenance department, but there's really little knowledge of how to take advantage of all the data, and this data, if we look at it on a per hour basis, you may have hundreds of thousands of dollars into the data, like the value of the data or the cost of the data to put in the system. So it's a huge part of the picture. One of the things I ask people, and this is something in the CMMS training effort, most times the training effort is organized around which buttons to push to get stuff to happen, like to print work orders, to print your PM tickets, to enter data. A lot of effort is spent in the configuration of the system, like how PMs are going to be handled, how this is going to be handled, what codes are we going to use for various things. But the question that I'm confronted with when I visit people after the system has been in for a while is how much effort in that beginning period was spent on the future use of the system, which is now the present. So we can put up the poll, and the question is, how much effort was spent setting up a system for future analysis? So at the time you put in, the system, did you consider and spend time training on using the system a year or 2 years from then? So you can say none, a moderate amount, or a substantial amount. And we'll take a second to wait for that to happen. Great. So that means that this group of listeners out there are significantly more involved in the future use of their systems than a typical group. Now, I want to look at some of the data. We can get summarized data out, which is pretty useful. It gives us answers to some questions, like the number of incidents, just the raw number of incidents. I was asked by an airport to say how many different times the escalator broke. So it was easy enough to go into the system and pull that up. Now, exception reporting is where you set up parameters and you see how many incidents meet or exceed the parameters. So you could phrase it like how many work orders were over $750, or how many used more than $5,000 worth of parts. The other summarized data is around PM data and the results of your PM effort. We're always looking for, we have a certain number of PMs, we want to see a certain amount of corrective actions. If we see too many, then our PMs are probably not frequent enough. If we see too few, then maybe our PMs are too frequent. We also have scheduling data and parts receipts and statistics. Now, many people are confused because the work order takes time away from the day. So if we look at our wrench time, typical maintenance workers spend 157 minutes out of a 480-minute day. They spend 157 minutes actually on the machine working. And you could just theorize easily that work orders take time away from that. That would make it fat. But work orders provide information to make better decisions, and better decisions are clearly lean. So we might make a better decision using the data in the CMMS for, say, a root cause analysis, so that we don't even have to do that repair again in the future. Well, that's really lean. The second thing we see is, and probably the origin of the work order in the 1950s was about written communication to the worker. Many of you have had the reaction or the situation where you told somebody to go fix something and they went and they fixed the wrong thing or the wrong machine, something on the wrong machine. So doing the right job right is always going to be lean. And having a written instructions of what to do where is going to increase the probability of the right job getting done on the right asset. Now, better machine histories are lean, because when you look back and see what happened, you can then decide, should we buy a new machine? Should we repair the old one? Should we refurbish? Should we make the part? Should we buy the part? All those questions are considerably easier to answer accurately if we have a good machine history. Now, the kindergarten level of good machine history is that the details and the incidents are in your system. And I tell people, go to your work order system, look at some random work orders. I'll talk about auditing in a minute. But look at some random work orders and ask the question, take a look and see if the fields are filled in. Are they readable? Like, more than readable, are they understandable? Are they, the kind of thing that is what I call actionable? And then, do the fields actually make sense? Sometimes, I like to say, if your work order says that you change the tires on a toilet, it may not, completely make sense. Now, our work orders, this is really an interesting issue, and that is our work orders serve many, many masters in our facilities and plants. What I mean by that is that the data is used by different parts of the organization. Obviously it's a cost collection document, so we can cost out different, work on different machines. But if you have any kind of safety or environmental compliance incident, that the PM system and the work orders are going to be one of the first things that are looked at. We also, many of us use the work order itself as a scheduling document. I've seen people have like a rack on the wall, and the work orders in the rack by priority, and people will pop off the top work order as the next job. So the physical document is used to schedule. We also have history. You can, as you sit there listening to this, you can raise your hand if you use the work order as authorization for parts. Many organizations, you go to the warehouse, the storeroom, and they're going to want your work order number. Same thing for special tools. Same thing for rentals. You know, even in some places, same thing for contractors. We also use it feedback to planners. You know, if you have planners, they use the work order as feedback to see whether their job plans were any good. It's used in various ways as a training document. Data for root failure analysis. If you have an insurance claim, insurance recovery, warranty recovery. Here's the thing. The thing about this is each of these items requires different data to do its job. You know, warranty recovery requires different data than proof of safety. Now, when you look at your work order, how many of these things are really being accounted for? Like, is there enough data there for root failure analysis? Is there enough data there for cost collection? Evidence in court is, you know, unfortunately, we're in a litigious society, so evidence in court is one of the worst, you know, bad use, but it's a use